Excellent. Good evening, good afternoon, wherever you are. My name is François Massonnet, and I'm the coordinator of the Sea Ice Prediction Network South, SIPN South. And today we'd like to present a few results that we have obtained over the past 4 years. You can see the logo on the first page of the presentation, and the logo says 2017 to 2019. Initially, SIPN South was intended to last for 2 years and to be one of the flagship activity of the Year of Polar Prediction Southern Hemisphere. But SIPN South has had quite a lot of success, and we decided to extend the initiative for several more years. So the new logo now does not feature those two years. So we are quite glad that there is some interest in the community to continue this exercise. So a bit of context. This is the Antarctic sea ice conditions over the past summer season. You see that the 2021 season has been quite in the average, a bit below the average actually, and we are spot on the average actually. When we look spatially at what happened, there has been some spatial variability in the sea ice concentration anomalies, but overall, when you average out all these anomalies, they tend to be quite close to the mean. To give a bit more of historical perspective, it's interesting to look at the anomalies of sea ice area since the beginning of the sea ice observations from satellites since '79. And I think there are two interesting things to note here. The first one is that obviously there is a very flat trend in sea ice area, but the other interesting feature is that the variance seems to be increasing as we go to the more recent years, and this means that there might be some high challenge in trying to forecast these anomalies for the coming years, because if the variance increase, the variability increase, it might mean that it's more difficult to predict those variations. The goal of SIPN South is first to try to identify all the existing efforts in the Southern Ocean sea ice predictability studies that are highly scattered across many groups, and to try really to build a sea ice prediction network community for the Southern Ocean, just like the one that exists for the Arctic. The second objective is to coordinate several seasonal predictions in the Southern Ocean. So each year we are opening a call, and we are welcoming many forecasts that we are intercomparing against observations. And then finally, that's more the scientific goal of SIPN South. We would like to understand what is the reason for the big spread in the forecast and for the systematic errors that we see, and I'm going to talk about that in a minute. This is the history of SIPN South in terms of numbers. So it started in 2017. The number of groups contributing has been quite stable. We are today having some 14 contributors, regular contributors, I would say, but there is some interest from other groups to join the effort, so we might expect a bit of increase in the coming years. What is also interesting is that each group can submit more than one forecast, especially those running dynamical models. They can provide an ensemble of forecasts if they want to assess the uncertainties of their forecast, for example, due to unpredictable weather conditions. And the number of total forecasts is actually growing. At least it has grown since the beginning. So that's a pretty good news if you want to resolve the statistical distribution of those forecasts. This exercise does not come out of the blue. Of course, we believe that there are a couple of mechanisms that exist out there in the Southern Ocean that allow us to provide skillful information a couple of months in advance. Sorry, I want to highlight two such mechanisms. One was flagged by Marike Holland in 2013, where they showed that there is some initial value predictability in the sea ice with the CCSM model, and then they showed in a later paper a sort of relationship between the octobosonal wind anomalies and sea ice formation anomalies in the subsequent falling in March. There is also evidence that the surface anomalies of the Southern Ocean do not stay at the surface, but they can be stored. So there is some predictability that can be stored at depth, especially below the mixed layer. There's been a nice study by Sylvain Marchi in our group who showed that with a suite of several models. And this is another example that leads us to believe that the Southern Ocean actually has some predictability well beyond the weather timescales that can impact the sea ice and the surface. This year we have had 13 contributors at the Southern Ocean's summer sea ice forecast for the SIPN South. There's actually a 14th contributors that joined later than the deadline, and those use different sort of tools, coupled dynamical models, statistical models, or ocean sea ice models forced by atmospheric reanalysis. The first diagnostic that we always look at is the total Antarctic sea ice area. So that's the integrated area of sea ice day by day since 1st of December. That's the day of initialization. So we request all the contributions to come in by the 30th of November. And well, on average, the model tend to have the right mean value. There is some spread intermodal plus intra-model, so across the members of the same model. But when you look at this, you would say, okay, that sounds reasonable. There doesn't seem to be a big issue here with the forecast. What's interesting is that there's actually a lot of spread at the model level. And this graph shows the February mean sea ice area for each of the forecasts that we have received. But look in particular, look at the spread for the dynamical model contribution. So those featuring a lot of members. You can see, for example, the purple model at the bottom. That's the UCL, so all group forecast. You can look at the ECMWF, the brown one, the Met Office contribution, and you can see that the spread on the mean sea ice area is basically as large as the spread of the interannual variations observed since '79. So it means that at 3 months lead time, it's difficult to predict the total sea ice area, or at least we need a lot of members to have a mean that is representative of what might actually occur. A second diagnostic that we like to look at is the integrated ice edge errors. So that's a way to measure the spatial disagreement between observed and forecasted ice edges. The integrated ice edge error is calculated as the sum of all the areas where you have an overestimation by the model or an underestimation by the forecast. And when we compute this integrated ice edge error, the very interesting thing is that there seems to be a better performance for the models that are based, the forecasts that are based on the statistical approaches. So what you see here, I made a slight error here. The RV should be in blue, so blue should be for dynamical models and orange should be for statistical models. You see that statistical models tend to have a lower error, lower integrated ice edge error than dynamical models. So it really highlights that those dynamical models, they struggle to simulate the sea ice area because of their spatial biases in sea ice concentration. Note also that there has been a two-day data gap problem with the sensor on the satellites, and this affects all the products. So this is why there is this strange behavior here on the 20th and 21st of February. Last thinking for today, I would like to ask a very open question, is because we saw at the previous slide that there seems to be some superiority of the statistical forecast. So the question I want to ask is that it, and do we just, close the discussion here, or is there more to discuss about that? And what I find interesting is that the dynamical model forecast, who contribute a lot of members, like the Met Office that you see on the left, contributing 42 forecasts. These dynamical models are certainly biased, but the advantage of those forecasts is that they have a spread that, in my opinion, is representative of what we could actually expect from the unpredictable weather variability. Ideally, you would expect the observations, so the observed ice edge is in white here. You would expect that observed ice edge to be always in between the 0 and the 100% probability of sea ice presence, of course, because you don't want your model to say there will be ice and actually there was no ice, or the other way around. When you look at the statistical forecast that performs the best, that's the Nico Sun, so that's the name of the guy providing the forecast, statistical forecast, you see that, of course, it has a low bias, but that in many regions, there was no ice forecasted while there was actually ice in the observations. And this is an analogy that I put here at the bottom with archery. What do you want? Do you prefer to have something that is accurate in the sense that the mean of your ensemble is close, or your ensemble includes the observations in the end? Or do you prefer to have something that is highly precise, but probably a bit off the target? And that's an open question that we can, of course, discuss later. I finished by saying that all the material that I've shown today is available from a GitHub repository. We try to make everything transparent and accessible to everyone. So the data, the scripts to make the figures are all on a GitHub repository, and there's also a website for SIPN South that you can access from the URL on the top. In conclusion, I think that there's going to be a lot of interest for Antarctic sea ice predictions in the next years, certainly, because Antarctica is becoming a hotspot for research, tourism, scientific campaigns. It's still extremely difficult to forecast sea ice conditions a couple of months in advance, although there is some evidence from theoretical studies that it should be possible. Today, what we see is that statistical contributions seem to outperform the dynamical model contributions. I have to say that most of the dynamical model contributions are not bias corrected for their biases, although we know it's possible if we have sufficient observations. And the last item I would like to flag is that next year there will be a special observing period of the year of polar prediction that will be centered around the fall 2022. Where we are going to coordinate an extraordinary SIPN South exercise and to see what is the ability of the models to forecast the fall conditions. I thank you very much for your attention, and I'm happy to take any questions by email or during the discussion that we might have during the workshop.